Hello everyone, welcome again with another session here led by me and presented by me. Thank you a lot for being here this evening. We are going to talk a little bit about DevOps and other concepts that surround this topic. So it's a really amazing subject. So that's why I'm getting so excited to talk about this, because it's one of my main skills right now. So hello Roger, hello Marcus, and welcome. I will give wait some minutes until everyone is getting online and watching here. But this evening we are going to talk about DevOps and how we can think about DevOps in the proper way. So instead of talking about very tech things, so for example, how Jenkins works or something like this, I think it's better to understand the ecosystem. So to understand the concepts that is surrounding or the concepts that are surrounding this topic. So it will be more productive in an interview, for example. So one of the things that I'm really doing during my career, for example, for DevOps, it's important to know other things before starting doing DevOps. So when we start being a good developer, you are a very strong candidate to be a good DevOps, because you understand the pains and the pros, the cons, and etc. of being or creating something. So it's really nice when you have a background of as a developer to do this very well, so to do DevOps very well. So later I will use a few minutes to answer every question. So we are going to follow some topics here, and later I'm going to answer every question that I get here from chat. I think everyone is listening well, and yes, everything's okay. So let's get started. The first thing that I would like to talk to you about DevOps. Usually when we talk about DevOps, we are going to talk about quality or quality assurance, but mainly for two reasons. We want to increase the scalability of our systems. So how we can get the spikes on load. So if we have a massive number of users using our system, how can we guarantee that the system will work? So how can we handle this spike on load? And the other thing that we are trying to get from DevOps, it's availability. So these three words resumes what startup wants right now. So they want automatization of everything, and later they want scalability, and they want availability. So the system is elastic enough to handle spikes on load, and we don't experience a lot of downtime. So the system is healthy most of the time. So these three words, it's very important to the companies right now. So because we have a massive number of users because of the internet. So everything is connected, everything is has an IP right now, an IP address. So everything can connect to our system. So we need to be able to handle these spikes of load, and will be handled to the availability too. So we need to make sure that the system is always, or at most of the time, available to the user. So let's start here. So what is a DevOps? So it's every time or everywhere that we see this word, we saw it's a dev with operation mind, for example. So it's the junction, it's the mix of two positions. So it's a developer with operations skill set as well. So basically it's developers doing operations. So developers helping the infrastructure team to get a better product at the end, so a better product on production. So, but what this means in practice? So it means that we are going to store most of the operations thing in code. So we are going to use a lot of code to do operations. So if we want to put a version of the app on the server, we are going to use code for this, or we are going to use software for this. And we call this as automatize everything. So we are going to use machines to handle machines. So this is a very, very nice feature to increase the quality, the overall quality of the system. So it's a high demand skill set. When we are able to do this, it's on demand. So because it's not so easy to do DevOps, but it's easy to understand the DevOps process. So that was one of the objects of this talk today. So yes, I want to be a DevOps and I want to do DevOps. So what I want to do, or what I need to do this. So the first thing and the most important thing, do you need to know how to deliver manually an application. So if you know how to deliver an app manually, you can do DevOps. So why? Because we are starting automatizing things. So we need to code the machine or to code a service to handle this to us. So it's very important to understand how to put a new version of an application on a server, for example, or how I can test this application to find out errors or exceptions or whatever. So if I know how to do this manually, basically I can do DevOps, because we are going to automatize these tasks. So the first thing that the first tip here, understand how you can put the application on a server, for example. So how can you deploy, or how can you update this version on a server? So for example, if you are going to update a website, what tools are you going to use? You're going to use FTP, you are going to use rsync. So start thinking about this. How can you update this website, for example? So this is very important, because one of the things that I saw a lot of developers trying to do DevOps, but they didn't or haven't yet tried to deploy something, to deliver something before. So, and one of the things that I always give as advice, less new things at the same time. So if you are trying to automatize things that you don't know, it's harder to understand and to find out what is going on in the process. So try manually and later start introducing automatization on every task. So for example, if I want to start using DevOps or get used to the process, it's very important that we start with baby steps. So very small steps to get this done. So for example, normalize your dev environment. So if you're going to create a tool or a way to put things on server, you need to ensure that your machine, your local developer machine, it's the same or almost the same that the server is using. So try to normalize this. You can use a lot of tools for this, Docker, whatever. So you can use other virtualization tools to accomplish this, but it's important to normalize your local environment. So how can I have the most similar environment like the server that I have handling the real users, for example? So it's not an excuse. For example, in my machine works, so it's not an excuse. Okay, so we need to normalize our local environment. This task will give us clearly all the steps that we need to put or to make the next move. So when we normalize our local development or local environment, it's a very good thing to understand how we can do this on a server as well, okay? So, for example, another thing that we can try to do when we push a commit to master in GitHub, for example, try to trigger a new deployment. So if you put some code on GitHub, so if you get some commit to GitHub, try to put this code on a server in an automated way. So think about this. So how can I do this in an automatic way? So if we're trying to improving those steps, we're going to accomplish DevOps very well. And later you can start adding new quality steps. So you can start testing during this process. So instead of pushing directly to the server, you can test before. So basically it's the 3 steps that I started in my career doing. So I tried to normalize my environment. Later I start just publishing automatically, and later I start putting or adding quality assurance steps. So it's pretty amazing, okay? And this leads us to CI/CD. It's a very common approach to use with DevOps. So most of the teams that work with DevOps are working with this philosophy. So continuous integration is a task where we are going to test our code more often. So we're testing unit testing or integration testing our code more often. So every time that we push new code to the version system, for example GitHub or Bitbucket or whatever, we are going to run tests on this code. So we are continuous integration and testing the code. So we are continuous trying to see if we get some error in the early stage. So before we get this on a server, we try to get on the integration phase. So it's very, very nice to pay attention to this. So every time that I push new code to the server is going to test this code. So it's going to run unit testing, it's going to run integration testing, end-to-end testing. So it's pretty important that this code that I push to GitHub is tested all the time. So it's amazing because even GitHub can give us some tips about this. So for example, let me show a little project here. This is here. So for example, when we do this, we can see, for example, every branch. Let me see here if I can. So for example, every push of code to a branch, for example, we can see if it's passing through the quality process or not. So we are continuous integrating this code, we are continuous testing this code. So for example, there is one code here that's not stable enough. So this gives us a lot of information about this branch. So it's not green yet. So we always say that it's not green because it's giving an error. So for some reason, some test here is not running. Okay, let me see here if I can. Yes. So for example, for one server it passed and the other one it's not passed. So it's pretty amazing, and we can see here. Let me see here if I can so there is another service here, but we can see here that this version was not passing. So it's pretty amazing. So for example, we can see here, if we click on the branch and see the commits, we can see every single commit and the status. So it's amazing. When we have a big team, this is amazing. So this gives us a lot of information, okay? So we can ensure other quality feature as well. So for example, if we want to, in this case here, let me show something to you here. So for example, if I try to open a pull request from switch to neutron to master, for example, here in GitHub we can ensure that if this branch here is red, so it's not passing, we don't allow the pull request to be accepted. So we can't accept a red, the merging of a red commit, okay? And later, the other thing that is pretty amazing, when we open the pull request, so for example, let me see here, yeah. So when we open a pull request, we can ensure if the merged version is green as well. So this is very important to the quality assurance process. So if we're doing this very often, we can increase a lot the quality of our code. So when we are, for example, peer reviewing our code, or we have another developer reviewing our code, the developer doesn't need to review if it's green, if it's red, because there's nothing to review here. It's red, it's not passing, so your code is not stable enough. So the reviewer don't need to pay attention to this pull request, for example, if it's red, okay? So we can make the process move more faster and more smoother, or more smooth. So it's pretty amazing, works very well. So the other thing that we can do, so for example, if everything is green, so everything passed through the tests, we can deliver this code to a server. So we can put this code in a server. So if it's green, we can move this version to a device or to a server, to whatever. So for example, on the last project that I was working on, we did this with mobile apps. So if it's green, we start pushing the version to Play Store or to App Store and etc. So it works. So we can do this. We can ensure the quality of the app with automated ways. So we can make tools that test our code and deliver the code to the client. So it's not always servers. We can do this with apps. We can do this with front-end things. So we can, for example, build a React version of our app and put this in the service to be delivered to the users. So we can deliver this very often, whatever the type of the app that we are creating. So we can create a mobile app for this. We can create, for example, a web app, or we can create a background server or service and etc. We can use continuous integration and continuous deployment to improve the quality of the process. And for example, one of the things that is pretty amazing, when we are using continuous deployment, we start deploying things more often. So this means that the client can have the code, or they can have the service updated more often. So the client can get his hands on the code very often and very earlier, because we don't need a very bureaucratic process to deliver code. So it's pretty amazing, because we are trying to improve the quality of this. And it's very nice because we can have a more clear vision of the entire process. So if we can, for example, if we push code to develop branch, for example, we can deploy this to a specific server, so where the client can test things. And if we push code to master, for example, we can deploy this version to a production-ready server. So it's flexible enough to choose this kind of thing. And just to everyone be on the same page, when we say deploy, it's the same as install the software on the server. So when we are deploying something to production, we are delivering this software to production. Okay. So So when we are thinking about deploy, so I'm thinking about how can I put this version inside a server, for example, we have some strategies to do this. So it's not so simple, just get this version and put on the server. It's not that simple, okay? Because we are talking about high availability, out scalability and high availability systems. So we need to handle spikes on load, and we need to be online most of the time. So we need to pay attention to those topics. We need to ensure that we are not interfering with those topics. So it's really important to pay attention to this. We need to deploy, but we need to guarantee that the system will remain outscaling or with scalability, and the system will be available. So the availability of the system will not be affected, okay? So we have some strategies. The first one is, I think it's the simpler one. It's the blue-green deployment. So basically what we do here, we replicate our infrastructure. So for example, I have a new version. So I have my app running in a server A or in a server set, so I can have more servers running inside this guy here. And if I want to put another version, I need to do a different approach. So I start another environment the same way of this one, and I put version B here. So when I finished creating this environment here, I need to switch between them. So I try to switch them in an easier way. So for example, I can point the DNS from the server A to start pointing to server B, or the set of servers called B. Or we can use or switch using load balancer. So I can get my load balancer that I'm talking a little bit in a few minutes. So I can get this load balancer and point to the other group of servers. So it's nice these strategies because we can roll back if we want. So we have both versions running at the same time. And if anything gets wrong, for example, so if we got an error, if we face some problem, we can roll back to the old version. So it's a very good approach for delivering software. Okay, and later if the other version, so the new version is stable enough, we can turn off or destroy the old version. So we can just turn them off and destroy every instance that was inside this set of machines or this set of instances. Okay, so blue-green, it's easier. So we just replicate the environment, install the new version in this environment, and later we point to this new environment, and later we destroy the previous one. Okay, so blue-green deployment, we do this. We have here our old version, and later we replicate or mirror this with the new version, and we can just point here to the new version. So we keep the old version a little bit, and later we start destroying this guy here. Okay, so there is a really good question here from Rodrigo. Hi Tulio, how does this strategies deal with session replication for those users already using the system? There is a strategy and a configuration that we can do in load balancer. It's called, if I'm not wrong, drain users. So for example, if a user is using this specific version here, we try to not disconnect this user. So we keep him here, and so for example, we give a time for this. So for example, 20 seconds, 1 minute, or whatever, and later we point to here. So we try to drain these users, or try to make them finish their work, and later we start moving them to here. Another strategy, another thing that is good, So for example, if we are working with session, for example, it's nice to have the session stored somewhere else or in another service, for example. So if we are dealing here with web applications, we can have another server here where we can store the session. So if a user connects to here or to here, the user is not losing the session, okay? So it's pretty amazing, okay? We have another approach here, or another strategy called Canary. We can see this in Facebook or in other services. So for example, we can split the users in bunch of users, and we start applying those chains to this group of users. So for example, we try to put the new version just for a couple of users, and later we start putting to the other ones. So this is easier to test this feature and to test this new version without exposing every user to the new version. So it's pretty amazing. One of the companies that I saw doing this a lot is Facebook. So it's pretty usual we see some feature that a friend of us is not seeing yet. So they apply this to specific users, okay? It's a more complex scenario because it's not that simple. We need to split the users, so it's a little bit harder, but it's doable. So it's possible to work on this too. And another way of doing this, we can start turning off each instance from the old version, applying the new version, and moving to the new servers. So the load balancer, the guy that is balancing the request to those instances, start pointing to the new version. So it's a really good strategy as well. So when we have more than one instance running, we can do this. So we apply to each instance at time, okay? But there's a problem here. Imagine this scenario. Imagine that we are uploading our photo. So we are uploading our photo to for example, to change your profile photo, for example, and we store this photo on this server here. So the user was connected to this server, and we stored the photo here. What would happen when this server is applying the new version? What do you have any idea of this? It's in Portuguese. So where is the file that was there? So this is a very common problem when we are dealing with DevOps. So if a developer is not aware of this, the first thing that the developer is doing or should doing is try to store or keep the file inside the server. So in this case, the developer will store the file here. So this leads us to a problem because we can't destroy one instance because the server is keeping the state of the application inside it. It's not the best way of doing, and in fact it's the worst way of doing this because we're storing state inside of each instance, so we can't destroy this instance as we are doing here, for example, rolling deployment. Okay, so it's very, very problematic. So what we can do from this? So we can use immutability. So one of the concepts that we need to be aware, our servers need to be immutable. What is immutable or immutability? We need to create instances or servers that we don't store or don't keep state inside of it. So upload a photo, for example, I'm not going to store inside the server. And for example, we can't store a database inside an instance like this. We can't store anything that if we destroy the server, we can lose something. So if we destroy the server, we're going to lose something. We don't have immutability, okay? So how can we do this? So how can we ensure immutability? So we need to start storing how we can create a new server on code. So for example, Docker is this. So Docker, we create a container, but we tell what the container will contain. So we tell how to create this container for the application. So this is a way of creating server that they are immutable, okay? So if we need to store something, we can attach a server or a service that is providing us this kind of thing. So we can provide, for example, in AWS, we have storage that we can provide to it. So it's a really nice thing. So we need to think or rely on other services. So if we need to store a user profile photo, for example, we need to use S3. So we put there in a bucket and a storage system, and later we can grab this photo and show to the user. So it's a really common approach. Or for example, if I need to use a database, I can use ReactJS. So it's pretty amazing because I can have my database outside or elsewhere, and I can turn off my machines or I can turn off my instance without losing my data, because my data is stored elsewhere. So it's away of my app servers, for example, okay, or my web app servers. So we need to rely on other services. So it's really nice to see every single service that we can do. So for example, Amazon or AWS has a lot of servers or services that can help us with this. So for example, S3 for storaging, if we need something like disks or local storage, we can have this too. So there's another services for this. If we need to balancing things, we have other things too. So everything is a service there. So we can start splitting our application using these services. So if I need something to store my session, I can use Elastic Cache, for example, Elastic Cache, and use, for example, Redis or main cached, for example, and store there. So if I destroy my app web or my web app, I'm not destroying the session, okay? So what we want with this, it's outscaling, so we can handle spikes on load. So if we have out of sudden 1 million user, we need to handle this spike, and we want to have high availability. So we want to be the most of the time online, or most of the time available to the users. So we want this. So one of the actors that is pretty amazing, pretty important to this scenario, it's a guy called load balancer. So load balancer is the guy that's in front of your application, distributing the load between the instances. So here we are thinking more in scaling things. So we don't have just one server to handle everything, because it leads us to have a problem in availability, because if we have just one server, if this server for some reason breaks, we can't handle any request from the users. So we need to have at least 2 servers and healthy servers or healthy instances to be able to be available. So it's very nice thing. So load balancer will know which server is healthy. So and the healthier one will get more requests, and we can set, for example, if an instance is not good, for example, we can destroy this instance and start a new one, for example. Or if we have a spike on load, we can start spinning a new instance to handle this spike. So we can do this. So it's really amazing, because load balancer can help us increasing the number of instances, but it can help us decreasing the number of instances. So it's important to outscaling. We can think in scaling up and scaling down. It's pretty important to understand this. We just need to be able to handle spikes so we can spin more instances, but we need to be able to turn off some instances because we need to save money. So if we start spinning more instances, we are going to pay more money for those servers. So it's really important that we can increase and decrease the number of servers very often or in a proper way, okay? So here, let me show here. So the most important decision that we have when we are using an outscaling server or outscaling environment, it's the instance size. So for example, we can have 100 instances handling every request and etc. And for example, we can have then use it all the time. So if we have 100 instances used all the time, something is wrong, because we need to be able to scaling up and scaling down. And on average, we are going to save resources with this. We are going to save money with this, because if we are handling the spike of load, we need to be able to decrease the number of servers later. So for example, we can set the load balancer to start new instance during the working hours, for example. So we can increase the number of servers in a period of time. So, and start turning them off during the night, for example. So if we are able to do this, we are able to save a lot of money. So it's pretty important, and that's one of the things that it scares a lot of developers and ops guys, because for example, if you set this wrongly, or if you set this without knowing what you are doing, when you got a spike on load, you can pay a lot of money for this, because AWS will spin new servers until it's enough to handle the spike. So we need to be careful with this. So it's pretty important to pay attention to this kind of thing, okay? So the instance we need to be instance in the size not too smaller and not too big, because we need to be small enough that we can create new ones, but not bigger enough to not be able to create new ones. So it's hard to tell this, but one of the things that we can do and we need to do, we need to measure and test. So we need to start collecting data about this and starting testing. So we need to do the math and saw what's the best decision to handle this. So we need to be able to scale it up, scale down in a way that on average we are saving money, and we are not affecting outscaling and high availability, okay? So it's important to know that when we are talking about infrastructure and etc., we are talking about money as well, because if we increase the amount of resources that we are using, we can, for example, kill a company. So it's really important to be aware of this, okay? And one of the things that is important a lot, so for example, I need everything outscaling and etc. No, you don't need it outscaling at first, but you need to prepare your system to be outscaled. So one of the tests that I was doing a few months ago, I was getting some web apps that was not immutable and trying to move them in an immutable way. So it's pretty hard. So that's why I think, and I really believe, that a DevOps needs to be a guy with stronger experience in development, because if it's a guy most of the time related to operations, it's hard to see this kind of problems. So usually the developer tries to get a solution for a problem, but it's not immutable. So it's not easier to scaling, it's not easier to be available for most of the time, so it's pretty hard. So one of the things that I really advise anyone that asks me about this is you don't need autoscaling at first, but be aware and know how to do if you need. So if you need to do, you need to do this very fast. So for example, I've been studying this for a long time, I think for more than 10 years if I'm not wrong. And I got my first spike on load on a project 3 years ago. So I started getting requests on about 1 million or 10 million, if I'm not wrong, of requests through a server. So I started getting real spikes on load just 3 years ago. So but I was ready, I was aware of this, I was prepared to this. So this is the device. Know the things, start applying this inside the projects or in pet projects, and start studying this, because maybe you don't have the opportunity to test this at first, but later you can use this experience. So try to create something that is maybe scalable, but try to do this. So try to think about this. So be aware of this. Try to do the math and know how would it cost for your client, for example. So if we're applying for a job, we need to know how would it cost for the company. So if I start a new service here, how much would it cost? So it's important to understand, it's important to be aware of this kind of thing, okay? And sometimes you don't need autoscaling at all. So it's important to really think about this. So to really understand the business, the service that we are working on, because sometimes you don't need to handle this kind of spike on load. So it's more controlled, for example, so you don't need to pay attention to this. So it's a kind of operation or process that is pretty close to the business, to the strategy of the company, because sometimes we don't need autoscaling, or we don't need to start putting more complexity on the server, because the business model, for example, don't require this or something like this. Okay, so right now I'm going to read the questions here. Please make your questions on chat, and we are going to answer everyone. So let's see here. So one of the things that is important to understand here, I see someone talking about stateless or serverless. Okay, stateless, but we have serverless as well. Okay, I'm going to talk about both. Yes. So Rafael Galbi, stateless servers. Everyone is asking about stateless servers. Yes. So for example, I don't know here if everyone is used to use, for example, WordPress. And when we deploy a website using PHP and etc., it was very usual and very normal. It's a common scenario. We put the PHP code with MySQL database and the files there and etc. So we put everything inside one box. So what is the problem with this? If we need to destroy the server, we lose everything. So one of the things that we need to take care, we need to get this PHP code and put somewhere else. So in a server or in a service that can handle the PHP code. And we get the database and we can put on other service. So for example, RDS on AWS, where we can store the data there. So the server itself, so the PHP code itself, is not relying on data inside the server. So that's why the server is stateless. It's not stating things that can change the way the user is using or seeing the things, okay? So we are not storing things inside the server, okay? That's why we think about them in an immutable way. So we think about the servers in a mutable way. So they are immutable. So for example, one forbidden thing to do, you cannot log in your server using SSH and starting changing things. We do this just for debugging purpose. So if I'm trying to discover if anything is wrong, for example, I can do this, but we have other tools for do this. So we don't change the machine by hand. So we don't do this, okay? So many years ago, we did this a lot. So we started a server, we start changing things on production, for example, or on servers. So imagine this scenario. So if we are going to log inside a server and start changing the server, even if you have just one server, imagine that other developer or other operation guy, if you don't document this very well, is not aware of replicate this. So that's why we need to put every configuration, every step of setting the machine on code. So using Docker, using Docker Compose and etc. to orchestrate containers, but we can use in a different way to store this. So everyone is on the same page when we are talking about the server. So everyone knows what is deployed inside the server, okay? So yes, Rafael and other ones, Alberto. So we have the best way of scaling up and scaling down is using stateless servers. Tá? Então, so we don't store state inside of the servers, okay? So put this on your mind, on your head, and start to thinking how challenging is this? So one of the most asked questions, so if I'm putting the app on one instance and the database on the other instance, the time that I'm using to get the data from the database will increase, so it will take longer to get the data from database. So that's not really true. We are going to have a little delay on this or latency on this, but it's important to understand that we are thinking about how to handle spikes on load. So we can think about caching things. So instead of trying to get things directly from the database, we can try better things or faster things like cache and etc. So we can use other tools to fix this, this cost of getting data, okay? So everything is handled. It's possible to do. It's possible to improve, okay? So Marcelo Pontes, Google, for instance, exposed the actions on their database via API. A new deploy is a new API version. No need to roll back or worry about our applications using the DB. Yes, about the DB, we have a lot of approaches to fix this. So we can use migrations, so we can store the changes on the database on migration. So it's a file, can be a SQL file, can be a JS file or whatever, where we try to create a software to apply those changes on the database as well, okay? So in Amazon, for example, in AWS, we can set, for example, the first machine that is moving to here can run migrations, for example. So we can set this kind of thing. And when we are using migrations, usually the framework or the tool that we are using to apply migrations try to do this just once. So if I run this right now and I try to run later, the same set of migrations, the same set of changes on the database, the framework itself is smart enough to understand and to see that the changes was applied before. So this tool will not apply again, okay? But Marcelo Pontes is right. We can use DB as another API, so we can just consume data as API, okay? Roger Santos asked, but the database is the same. If I change a table for X, for example, I need to ensure if my older API works too. Yes, so that's why it's important to understand both sides. So for example, if you are dealing with this change, for example, we are going to, you need to remove a field on that table and you need to add another one. So what's the proper approach of doing this? On the long term, you are going to remove one field. So what's the best approach of doing this? We have a migration that adds the new field first, and this will allow both sides or both versions of the application work. So the new one will use the new field, and the previous one or the old one will use the other field. So when we ensure that every single instance of the application is using the new version, we apply another version removing, or another migration removing the old field, okay? So we need to think about how we can apply this, okay? And migrations can transform data as well. So for example, in this example, where we add another field, and if we need data from the old field to the new field, we can create a process inside migration, for example, to migrate this data from one field to the other one, and later the migration again will remove the old field. Okay, so we need to think about this, and you're right. It's a really common scenario. You need to update the tables. You need to remove or add some fields from there. Okay. Huberto Oliveira, so far, yes, stateless. That would provide better immutability. Yes. Marcelo Pontes. Yes, exactly as Marcelo said. We need to adapt our chains to be backwards compatible. So we need to handle these two versions for a while. Yeah, okay. Roger Santos said it's a challenging. Yes, it's challenging. It's not so easy. It's not so easy to advocate this. So it's not so easy to teach other developers how to do this, because developers just want to change things and don't give a shit for the rest of the things. But it's a really important thing to be aware. Okay. WebNose asked, immutability is recommended when using rolling deployments or whatever. Yes, it's recommended everywhere, okay? So if we do this, we can have the same environment on our machines, on development environment. We can have the same machine on developer branch, for example, and we can have the same machine or instance in production, okay? So it's a good practice to have immutability or immutable servers, okay? Yes, WebNose said, if I'm basically saying that we store things elsewhere, yes, exactly. So we don't store things inside the app or inside the web app, okay? So if we need to store data, we are going to store in ReactJS or in DynamoDB or whatever, but it's not, we're not storing inside the server, okay? It's pretty easy to do this, okay? We can just inject configuration or settings on the machine, and the machine will just works. So the difference between your version that is running on your machine to the version that is running on the server on production is just the environment variables that is telling which database to connect or which port to open or something like this. So it's the same application, just with the entry points or the variables changing. So it's almost the same when we have a car engine. So we have the engine and we have everything that we can put. So we can get that engine and put us elsewhere. So we can mount, for example, an engine of a car on a table, for example. We just need to inject the proper cables on it. Okay, so it's the same as a web app, for example, or an app. We just need to inject the proper configuration, the proper settings to be able to run this. So we can do this on local machine or in development or in production, for example. Okay. André Marçal, that's a good strategy. Okay. Because you rise and destroy servers depending on their needs. Exactly. So if we can handle spikes on load and we can save money, so we can handle spikes on load, scaling up, and we can save money scaling down. Okay. Timóteo Nascimento, how do you scale a relational database? We can add more servers. So basically we can have a master server and we can have some slaves. So the most costly operation, it's the write operation. So basically, usually the operation on database it's very expensive is when we are inserting or updating data. So but it's not the very usual operation. So probably the most common operation is to read data. So we need to read more data than we are going to write data. So what we are going to do, we start writing things on the master, that is the bigger one, or the master of the relational database, for example, MySQL, and the slaves we are going to use to read data. Okay. So usually we start creating a set of servers. So we have a master and some slaves, okay? And we have other strategies to do this. So we can shard, so we can split our database in parts. So for example, thinking about Facebook. So we can get the Facebook database and shard or split it logically in Brazilian users and US users, for example. And one of the most important thing about this, when we are going to look at the users, it's faster when we split this. So for example, if I'm a Brazilian, it's more likely to have Brazilian friends. So the data is closer. So we can do this as well. So we have other options, but basically we can have more servers, so a master server and some slave servers. And if it's not enough, we can think about caching things. So before starting spinning up or creating more instances of database, probably I would apply some cache strategies. So instead of hitting the database, I would hit cache first and keep things on cache, because it will be faster, because cache usually is faster than database, and it will cost less than if you are using directly to the database. Okay. Okay, Timóteo. As Rafael said, you can look AWS Aurora, but Aurora is inside RDS. So RDS is the service where we can create MySQL, Postgres, Oracle, if I'm not wrong, Microsoft SQL or SQL. So we can have those databases inside AWS as well. Okay. So exactly as Roger Santos said, one for write and a lot for read. Yes. André Didier, do you have experience testing web applications in the context of CI/CD? Yes. I have experience doing this with React, with backend APIs. We did this with mobile applications. So it works very nice. Sorry, one idea said about Selenium. So we are talking about end-to-end tests. End-to-end tests, in my case, as I'm using a lot of React, I don't do end-to-end testing because it consumes a lot of research. But we can do this inside CI/CD. Okay, so if you are able to run some tests using this, or Selenium or Puppeteer, that's really great. The team from Chromium released this a few months ago. We can put this inside CI/CD. Okay, so the most important thing, if you can do this on your machine, you can do this inside CI/CD server. Okay, so you are just changing the strategy or adapting this to run on a server. Okay. Rafael Galbi, do you know if Skip the Dishes uses AWS Lambda for serverless solutions? I don't know. It's not really clear about this. One of the things that I understand and I'm aware that's important to understand, it's we need to think about the options that we have. So, for example, it's nice to know that we have Lambda for some scenarios. It's nice to know that we have, for example, EC2 instance that can handle some kind of traffic. So it's important to understand that the tools that we have, and if we do this, it's easier to understand the power of this. So, for example, if you need to scale a profile photo, to me the best solution right now is using serverless solution, because we can run a Lambda function when we upload a photo to a bucket inside S3. So it makes sense. It's easier to do. So it's pretty important to understand what is Lambda or what is serverless approach and how you can apply this inside a project. Okay, so it's really, really important to understand this kind of thing. Marcus Vinicius said, do you know if Skip uses Jenkins integrated to Mesosphere, the COS? I don't know, but as I said here, I think it's important to understand the steps or the concepts before starting using tools. So it's really important to know this, how things related to each other. How can we, for example, if I know that a serverless approach, for example, is good for replying for changing something, I can use the same approach, for example, in Firebase Cloud Functions. That is the version, one of the versions of Lambda on Google. So if I know this, if I know this, it's very nice to I can change things. So I can use this on Microsoft. I can use this elsewhere. So it's pretty nice. Okay. Let me see here. Roger Santos, Tulio, please talk about Mesosphere, the COS. I haven't heard about this before, so let me see here. What is this? Yeah, it's almost the same that we are doing using containers. So as I saw here, just rolling and seeing the website here, it's a way of I forgot the word, orchestration. So it's one of the ways of orchestrating containers. What is orchestrating? So when we have a lot of pieces. So if we have a lot of containers or a lot of boxes splitted around, we can have a service called orchestration that can handle this to us. So for example, if I need one MySQL server, one cache or whatever, so we can have orchestration to organize this to us. So AWS has this inside. Google tries to force us or tries to encourage us to use Kubernetes. So it's a way of orchestrating the structure, okay? But I'm not used to use Mesosphere, and I really don't know if they use this, okay? So it's important to read about this and see if how this tool, for example, is applied inside this context, okay? Okay. Yes, it's a pretty amazing way of applying updates to our services and servers as well. Okay. So, anyone have more questions or questions? Guys, one of the things that I really think it's really important. So try to get your hands dirty, okay? So DevOps, it's beautiful, it's nice, whatever, but try to create a simple API, okay? So try to, for example, use JSON Web Token and create something that connects to MySQL and return some data, okay? Try to do this using Docker, and later try to put some unit testing on it, later some end-to-end testing, integration testing, and etc. Run on your machine, later try to move this to another server, for example, or to a continuous integration, continuous deployment service, and try to do this there, and later try to understand this process, the whole process. So that's why it's DevOps. It's not so ops. We have the dev part as well. So it's important to understand what the kind of thing that we need to do as developers and the kind of thing that we need to do as operations guy. Okay. So if you want to start with continuous integration service, we have Travis. That's nice. So we can use this for public projects in a free way, okay? So it's pretty amazing. And we have other solution called CodeShip. So we can use this to start using CI/CD without needing to pay attention. For example, if we are going to use or run Jenkins, for example, Jenkins is pretty hard to set because you can have a lot of problems inside Jenkins. So my advice to you, my final advice to you, if you are going to try CI/CD for the first time, try to do this using our Travis or Semaphore CI. So try to use one of those tools. So it's easier. So we are going to focus on small things first. So we are going to try the whole process, to try the process of using CI/CD, DevOps. You are going to be forced to use DevOps because, or thinking in a immutable way, because it's not possible to test if you are not doing this. So try those tools and starting creating something to practice this. So it's pretty important to be clear of this. So before the interview on Saturday or Sunday, it's important to try this. So get your hands dirty. So put the hands on your code, on the servers and etc. and try to do this, okay? I think it's the most valid advice to this. So try to see the problems using it. So try to use it really well, okay? Guys, thank you so much for having me here, and thank you so much for listening to me for more than 1 hour in a row. And thank you a lot, and I wish all of you have a good luck during the hackathon. And I saw, if I'm not working on Canada yet, but I said to everyone, if you are going to work there, remember me and we can get a beer there together, okay? So thank you a lot for your time, thank you a lot for your patience, for your questions. It was very amazing to be here and share a little bit of my experience with you, okay? Thank you a lot, guys. If you need some help or anything, just send an email to me, contato@devplano.com, and we are going to run an event about ReactJS. So it's called Hands-on ReactJS. So devplano.com/hands-on ReactJS. And I see you around. Thank you a lot, okay? Good luck to everyone. Bye-bye.